Welcome to this week's Contrarian Coding News. The current dominant narrative surrounding the Crystal programming language positions it as fast as C, slick as Ruby. This tagline highlights its compiled nature and performance, along with a syntax familiar to Ruby developers, aiming for a sweet spot between developer productivity and execution speed. Crystal is commonly seen as a strong contender for web services, APIs, and CLI tools, leveraging its static typing with advanced inference, concurrency model, fibers and channels, and easy C bindings to offer a modern, efficient development experience. However, this mainstream perception, while well-intentioned, may be an albatross hindering Crystal from achieving its true disruptive potential. A disruptive, unorthodox, and rebellious contrarian viewpoint is that Crystal's Ruby-like syntax, far from being its greatest strength, is actually a hindrance, and its true power lies in its un-Ruby-like compile-time metaprogramming and systems capabilities, which remain largely underexplored and under-leveraged. Argument: the slick as Ruby promise, while appealing to a segment of developers, fundamentally misdirects Crystal's identity and adoption. Crystal is a compiled, statically typed language, which means it cannot, by design, replicate the dynamic, runtime-centric flexibility that defines Ruby's slickness, e.g., open classes, extensive monkey patching, and runtime reflection. This creates a close but different paradox for Rubyists, leading to frustration when Crystal doesn't behave like Ruby, or prompting them to question the value proposition over established, fully dynamic Ruby ecosystems. Simultaneously, developers seeking robust, low-level systems programming often overlook Crystal in favor of Rust or Go, failing to see its unique blend of expressiveness and compile-time power. The truly disruptive potential of Crystal, however, resides in features that starkly contrast with Ruby's runtime dynamism, its powerful macro system, and its seamless C bindings. These capabilities allow for sophisticated compile-time code generation and direct interaction with low-level libraries and hardware, a paradigm fundamentally different from Ruby's dynamic approach. Critique of slick like Ruby. Ruby's slickness is rooted in its runtime dynamism, where code can be modified, extended, and inspected at execution time. Crystal, by its compiled and statically typed nature, sacrifices much of this dynamism for performance and compile time safety. While the syntax is superficially similar, the underlying programming paradigm is distinct. Promoting the slickness creates a cognitive dissonance for developers expecting Ruby's flexibility, leading them to perceive limitations rather than appreciating Crystal's strengths as a compiled language. The industry's gradual shift towards optional static typing in traditionally dynamic languages like TypeScript for JavaScript or Sorbet for Ruby indicates a growing desire for compile-time guarantees. Crystal offers this intrinsically, but its marketing often understates the depth of this compile-time power by focusing on a familiar surface. Embrace the un-Ruby. Crystal's macro system is not merely a convenience. It's a powerful tool for compile-time code generation and static reasoning based on type information. This allows for the creation of highly optimized code, domain-specific languages, DSLs, and the elimination of boilerplate before runtime. This is where Crystal's C-like performance truly merges with its slick expressiveness, not by mimicking Ruby's runtime, but by elevating compile-time capabilities. A truly contrarian view would advocate for Crystal to lean into generative programming and type-driven development through macros, fostering a culture of creating highly optimized, custom binaries that are syntactically clear, yet semantically rigid and efficient, akin to advanced template metaprogramming in C++, but with a significantly more approachable and type-safe syntax. Rebellious Niche, the smart firmware language for performance-critical, generative applications. Instead of competing as a general-purpose web backend language, a crowded market where it struggles for mindshare against Go and Rust, Crystal could redefine its niche as the premier language for highly specialized, performance-critical applications demanding custom, compile-time-generated code. This includes high-frequency trading systems, where nanosecond-level performance is critical and static guarantees are paramount. Macros could generate and optimize trading logic directly at compile time. Advanced embedded systems and edge computing. Beyond simple IoT, leveraging small binary sizes and C bindings for complex custom firmware where runtime overhead is unacceptable, but C++ development is too prone to errors or too slow. The ongoing work on Windows support becomes less of a blocker in these Linux/bare metal heavy domains. Compiled game logic/scripting. Providing a high-level, readable syntax for game mechanics that compiles into extremely fast native code, offering a safer and more performant alternative to interpreted or JIT-compiled scripting languages. Evidence and historical patterns. The scripting language trap. Many languages initially gaining traction as scripting languages, example Python, JavaScript, eventually improved performance through JITs or native extensions. However, they often retain fundamental dynamic pitfalls when pushed to large-scale, performance-critical systems. Crystal, by being compiled from inception, bypasses this trap, but is conceptually constrained by its Ruby-like marketing. C++ template metaprogramming's power and pain. While notoriously complex, C++'s template metaprogramming demonstrated the immense power of compile-time code generation for extreme performance and domain-specific optimizations. Crystal's macro system offers a more accessible and arguably safer avenue to similar compile time power without the C++ syntax and compilation burden. The Go versus Rust conundrum. Go prioritizes simplicity and fast compilation for networked services, while Rust prioritizes safety and control for systems programming. Crystal often finds itself awkwardly positioned between these two, attempting to embody both. The contrarian viewpoint suggests Crystal should embrace its unique, compiled Ruby syntax with macros identity to solve problems that neither Go, with its simpler type system and less flexible compile time capabilities, nor Rust, with its steeper learning curve and different approach to metaprogramming, address as elegantly for specific, specialized niches. By intentionally shedding the expectation of being a mere faster Ruby and instead focusing on its core strengths of expressive, compile-time code generation for high-performance, specialized systems, Crystal could unlock its true disruptive potential, define a less competitive and higher-value niche, and move beyond being perceived as a wannabe in multiple categories to become a leader in a uniquely demanding one. And that wraps up another edition of Contrarian Coding News, where the status quo is always up for debate.